Hello there, my name is Edera Wangui, and today I'm bringing you a new SQL video. We'll be covering SQL commands and we'll mostly be going through SQL introduction. Welcome, and I hope you learn and come back for more at Code Darasa. It's where it's at. Let's look at SQL commands and some basics. The first thing we're going to cover in our video is importing a database. We're going to look for a sample database on the internet and import it to our Postgres instance and view it on pgadmin. So I'm going to get this from Neon. They have a sample Postgres database that you can use, so that's what I'm going to use. So I download it. Download DVD rental sample database. You'll get a zip file, so open it and export it. I already have done that. So let me go to my command line, and you want to run the pg restore. So first of all, we now have the database. What we need to do is create a database for this and then load it there. So the database creation part, that we still have to do on our own. I'm going to enter a PSQL instance. I'm already in it here, so let me clear and create database. Database DVD rental already exists. So let me look at all the databases we have. We have DVD rental, Postgres SMS, template 0 and template 1. We want to drop that database so that we can create it again. I'm trying to reproduce this the way you would have on your end. Don't forget the semicolon like me. It's being accessed by another user. So what I'm going to do is come here and just remove it from here. Delete. Let me just remove it from pgadmin. So we no longer have it. When I try to delete it now, it will tell me it doesn't exist. So that's good. So let's create it, and we have our database. So to load it, we're now going to use pg restore, and then the user, use your user, Postgres user. For most it's Postgres, and for my case it's the name of my computer, which is Waithera. So use that, and then the pwd the location of your database, the one that we've just downloaded. So after that, we have it. We have some errors, but you can see it ran successfully while processing, alter type, MPP rating. So we can now join. Let's connect to our new database, DVD rental. We're now in, and list the tables. We can see we now have tables associated with this database. So when I refresh this on pgadmin, I now have DVD rental, and as you can expect, of course, I have my tables. On our last video, we created an SMS, that's a school management system, in short, database to store our data. So before creating anything, any tables or inserting any data, let's go through a sample entity relationship diagram. So what is an entity relationship diagram? It's a way of modeling, of displaying your connection between the different tables and the values they contain and the type of keys they are, the data types they are, and all that, yada yada yada. So we have an example here. I'm not going to start it from scratch, but I can explain it. We have a student, we have a subject, we have a teacher, we have a classroom, we have a class, activity, duty. So the relationship is one duty has many students. One student can only have one duty, so it's a one-to-many relationship. One student is related to a subject. Let me put this here so that it's more clear. One student can have many subjects, and one subject can have many students. So we have a joiner table because it's a many-to-many relationship. One subject can have many teachers, and one teacher can have many subjects. Again, a joiner table, subject, teacher. One teacher can be assigned to many classes, and one class will have many teachers. So another joiner table there, teacher class. One class is assigned to one classroom. No, one class can have many classes. Many classes come and use that class. So it's a one-to-many relationship. Again, this is my interpretation of it. Feel free to redefine this your way according to how your schools work, because especially something I expected to be a bit conflicting is the concept of class and classroom. So class, I'm viewing it as the many collection of students who take subjects together. So that's what I'm calling a class in this case. I felt like I need to explain that so that we are on the same page. And classroom is the actual physical building, the room that they are taking this class on. So a classroom can have many classes in that case. Technically, a class can have also many classrooms, but I'm not trying to complicate this. So my current relationship is one classroom has many classes. You can make it as granular as you want. You can you can literally continue making more tables for this, and that's okay. So that was just, I thought I should explain that. One student can have many activities, and one activity will have many students. So I felt that was straightforward. So we have a student activity table. So in total, we ended up having 12 tables, and you can see the different columns they have and the different, we have checked our entity relationship diagram. So that was it. Let's get into the fun parts, SQL commands. We have different types of SQL commands. We have DDL, DML, DQL, TCL. We have data definition language. What is data definition language? It refers to a set of SQL commands used to define and manage database structures. These structures will be tables, indexes, schemas, constraints. It includes commands to create, modify, and delete database objects, allowing for the setup of the initial structure and any subsequent changes. Let's look at examples of DDL commands. We have create. This is a common one. Create table. We create the table. We have the syntax on the left and an example on the right. So that's the logic. For instance, here, create table, student, ID, serial, primary key. We'll get into all these things later. But basically, ID is the name of the column, and the data type is serial, and then the constraints, that is the primary key. We have another one, alter, modifies existing database objects such as adding, modifying, or deleting columns in a table. So we do have an example here, adding a column, modifying a column, and also dropping a column, and many other more. You can change constraints, that too. And the third DDL command we have is drop. So drop table, student. You can also drop index. You already saw me do that. So for instance, here I had all these tables created. I ran this command, drop table, and was able to drop all my. So if I run this again, it will tell me they don't exist because I have deleted them. And now let's look at the last DDL command before going to the code. We have deletes all data from a table without deleting the table itself, often used for quickly clearing data. We're going to bring this back later because we also have a different way to delete data, which is using the delete command. Anyway, truncate table and then the table name, and that will clear all the data and also reset your serial, for instance, the primary key. If it was starting from 1, it will reset that from the beginning, which will be good instead of now starting from, let's say, I deleted the last 20 records and now it's starting at 21. That's another advantage of truncate. Before we move on to the next set of commands, let's try and create some of these tables we had. We have the different, I showed you the different columns and their data types. So here, let's look at 2 examples really. We have a classroom, they have ID, serial, primary key, capacity, number of students. Technically, later we'll try and have number of students be a generated column, but for now we're sticking to the basics. So we'll assign it an actual manual figure, but ideally it needs to be computed because every time a student is added, it needs to be recalculated and updated. automatically. And then the name. We have a teacher, we take the first name, last name, the level of education, and whether or not they are a class teacher. We have duty, the name, and the number of students in that. Again, that can also be a generated column where we go and query all the students assigned to a specific duty and now give that value instead of having a manually updating every time we add a student. Let's go add one extra, like let's go add the count. Class, again, name, number of students, classroom ID, prefect ID, class teacher ID, and the performance history. Here I used small int, an array. It will basically be a list, an array of ints. So of course this is not the best way to track this, but I'm assuming maybe the classes compete with each other, and this one was the first one. So 1, 2, 3, 4 if they add 3, if they have 4. So 1, the last time you were 1, the next time you were 2, back to 1, something like that. I also believe schools don't track classes in general, they track the actual students. So that was just me explaining my thought process. It doesn't have to be the common case. And lastly, I'll cover subject because the others will mostly be the foreign keys, which we don't have to track. So student has first name, last name, class ID, classroom ID, the duty ID, and whether or not they're prefect. And something to track with subjects is ID and name. You could track things like the subject code and such things, depending on you. I mean, I'm just giving you ideas. And then most of that will be the joiner tables, which will mostly contain the subject ID, like the two different columns that from the two different tables they're joining. So that's create. So let's do this create. It says here I lost the database connection, but I've rerun it, and when I refresh, I should have my tables. So we have looked at the create command. Let's look at the drop. Why not? So I'm going to drop all these tables I just created. When I refresh, I've lost them. So you can see the syntax for dropping, drop table, and then the table. Anyway, we came here to build, not destroy. Both are equally relevant, but I digress. We've covered data definition language. Let's go to a different set of commands. That's data manipulation language. So what is data manipulation language? It's a subset of SQL used to manage and manipulate data within database tables. So these will be updating, inserting, and allowing users to modify the context of a database without altering its structures. So examples, we have insert, and the syntax is insert into the table and the different columns and then the values, of course respecting the data types. Update modifies existing data in a table based on a specified condition. So update student, set last name to currently, where ID is equals to 1. Maybe a student has changed their name, maybe they've changed something else and we need to update. So that's where the update command comes in. And lastly, we have delete. Delete removes rows from a table based on a specified condition. Again, just like truncate, it does remove rows, but the difference is we are using a condition. So let me show you an example. Let's insert some data into our tables. I do have some sample data. I'm not going to go through each of them, but I'll go through some of them. We have classroom, the capacity, the number of students, and the name. So here's how you do that. And notice how I didn't include the ID column. This is because it's auto-incremented, so I don't need to actually provide that. The database will keep generating that for me. So same case for the teacher. Level of education can be college, university, whether or not they're a class teacher. The different duties. So I have dining hall, I have toilets, I have cleaning pavements, I have classrooms, and the social hall. So class, examples of these are class of 2012, the classroom ID, prefect ID, like who's the prefect assigned to this class, the class teacher ID, and the performance history. I sort of explained this, so that's where it's at. And last thing I'm going to cover, should that be the last thing? Yeah, technically. Yeah, my subjects. I have the usual ones, mathematics, English, Kiswahili, physics, chemistry, biology, geography, history, agriculture, computer studies, business, home science, and music, and a different set of students. And whether or not they are prefects, that's one. Like, we have 3 prefects here because we do have 3 classes. So each class has one assigned student as a prefect. And like I said, the joiner tables, these mostly columns, the primary keys of the joiner of the tables you're joining to. So no need of going through that. And of course, activity, we have drama, we have music, we have hockey, we have football, basketball, swimming, and the number of people there and performance. Again, maybe there's a better way of tracking this, but we're doing this for the vibes. I have a student here whose name I want to change very much. So here's my chance. We have this student, Karindi Mwende. And Karindi Mwende, the reason I want to change the name is because their name is not capitalized. This is because when I'm going to order, I will end up, they'll arrange the capital letters first and then the small letters first. And I want them to still maintain the alphabetical order. So I could choose to enforce that, but what I'm going to do is just, since it's the only one, let me just change that. So anyway, mostly an excuse for me to use the update command. So select all from student, and I want specifically give me all the students where first name is equal to Karendi. So I don't know the ID number yet, but okay, technically I know. It's the first ID. So I have that. Anyway, so update student set first name equal to Karendi with a capital K, where first name is equal to Karendi. So we run that. Update one update. So now when I run, Karendi is gone. No, they're not gone. They are still there. They're still the first ID. So they're now updated, and it's now a capital letter instead of a small letter, which is what we wanted. So we've gone through insert, we've seen update, and I can do the same for delete where. So technically, delete, unlike truncate, takes a where condition. But it can also work without the where condition. You can still say delete from student, and it will delete all the data in the student. So for a student, I can do that. Let's continue. We have covered DML and DDL. The next thing we're going to cover is data query language. This is one of the most common commands you've seen. Select all from table. Okay, when I say all, I mean star. It is a set of SQL commands that are focused on retrieving and querying data from databases. They enable users to extract and organize data to meet specific information needs. So what are some examples? The only example really is select. It is used to query and retrieve data from one or more tables. It includes various clauses to filter, group, and sort data. An example of these is select first name, last name from student. We've seen already select a lot, select all from student. So that's a basic one. But here we are specifying the columns. Select all the columns from table student where ID is greater than 10, grouped by class ID. So technically group by comes in when we are aggregating, but we're going to deal with that later. And then order by first name and last name. And that's fun. Now let's get into the fun parts. We've mostly covered most of these. So we've seen how to select all from classroom. I don't need to run this, but let me just run one of these. Select all from classroom, select all from class, select all from teacher. So they tell us fetch all the teachers that are class teachers. We saw that some teachers are class teachers and others are not. You can say select all teachers from, so select star from teacher where is class teacher, or is class teacher is equals to true. let's look at what the data already looks like. So we have false and true. So you can say where is class teacher is equals to true. But a shorthand for this is just removing that, because is class teacher will be truthy, and it will end up bringing up all the teachers that are class teachers. So here we see Mwende, Kalendi, Mokiri, Mwendoe, I wrote that wrong, and Kiran Kendi. So we have been able to fetch all the teachers that are class teachers. Similar to that, let's fetch all the students that are prefects. It will be the same, except we'll be using the is prefect here. So we do have 3, Kimadi Monene, Martin Sororo, and Karendi Mwende. Fetch all the students in Kifaru. So what is Kifaru in this case? We use the classroom ID. So ideally, we would be joining to the table classroom, but I'm trying to not going to join yet. So I'll go to classroom and get the ID for Kifaru, which is 1, and then come back here and select all from student where class ID is equals to 1. Or I can also do a select statement where classroom ID in, and then I give a query. So select all. No, I want to select ID from student where, not from student, from classroom. I want the classroom that is called Kifaru, so I'm going to just copy Kifaru. So where name is equals to Kifaru. So I have a query within a query. So select all the IDs from classroom where name is equals to Kifaru, and then when I get that, get me all the classroom IDs that are in this list. So you've seen 2 ways of doing this. Of course, there's a third way using a join, but I'm trying to be as simple as, as beginner friendly as possible. We'll dive into that, we'll cover all that. We're seeing an error here, classroom ID does not exist. This is because of this. So we have classroom IDs 11111, and these are all the students that belong to Kifaru. I could also change this. Again, when we get to join, we'll make this a little more fun, which will be fun. But you've seen 2 ways of doing this. You can go to, I can run this query here and get the actual ID, and then say classroom ID is equals to that ID, or I can also have a subquery, which is what I also did. So those are 2 ways. Another question we could ask ourselves is, fetch all the students from the class of 2014. So who is the class of 2014? We'll do a similar query to that. So we can go get the class of 2014, the ID is 3. So this is what I did here. It gave me 5 students, Mate, Mwaki, Mwende, Mokepi, and Waridi. So similar to that, you can also do the select ID from class where name, in this case, right? Yes, the class name is class of 2014. So just copy that so that you have it right, but don't worry, you'll still get it. It will be case sensitive, so be careful about that. Fetch all the students from the class of 2014. We've done that. Fetch count of students by duties. So I basically want to know for each duty how many students are here. So if it comes to, let's first look at the duty table, what that looks like. So select all from duty. Don't worry, there are not many, so it won't be overwhelming. Select all from duty. We have 5 duties. So we want to group all of these by, we want to, for dining hall, I want to know the number of students assigned to dining hall. Ideally, we'd also join to the duty table so that I can get the name, but we're trying to be very simple. I keep repeating that. That's the last time I say that. Philippi. Anyway, select count all and then give me the duty ID from student group by duty ID. So here we can see that we have 3 for duty ID, 4, we have 3 for 2, we have 3 for 3, and 4 for 1, and 3 for 5. So basically that's given us the count of students by their duties. So group by ideally is used for such aggregations when I want to give me the minimum, the mean student in this category, give me the sum I aggregate and group by duty ID. So basically that's what the group by function does. It helps you group and then have an aggregate function. We'll cover aggregate functions soon, so don't worry, all this will be more clear much later. Fetch all students, order by their first name in ascending order. So give me all the students and then order them by the first name. So these are all the students. We start with, if they're ordered by the first name, remember here I said in ascending order, the default ordering is ascending, so I didn't have to specify ascending. By default, it knows what you want. So we have G, K, 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 M, and you can see they are arranged. We have Namaganda and Waridi at the end, W. So they are arranged in ascending order by the first name. So fetch all students ordered by the last name in descending order. So here we're using last name as the ordering key. So we have Nwaji, that's the last, alphabetically the lowest level, the highest level. You get what I mean? And we have F, which comes way earlier. So basically we start from N, which comes way later, and F, end with F, which comes way earlier. In the alphabetical order, of course, and we are ordering by last name, and here we had to specify descending, so DESC does that. If you wanted to be explicit too, you could also use ASC, but it's not relevant. But if you need to do that, the keyword for that is ASC, which is the equivalent of descending, DESC. All right, let's look at the next one. Fetch all students, order them by duties with first name in ascending order. So 2 things, we're ordering by duty. So I'll go through duty 1 and list all the students in duty 1, go to duty 2, list all the students in duty 2, go to duty 3, list all the students. So as you can see here on the duty ID column, we are going through 1, 2, 2, 2, 2, 3, 3, 3, 4, 4, 4, and so on and so forth. And I didn't specify the ordering, but by default it's ascending. And then after that, we also order them by first name. So within these, we have Karendi coming in first, Muiswedi, Moendia, and Waridi the fourth. Same case for, now notice how this ordering has been changed, because we're first ordering them by duty ID, and then after that, within the duty ID, ordering them by first name in ascending order. Another example of a question we could ask ourselves is, fetch all students that clean the hall. Before cleaning the hall, we need to know what ID the hall is. Again, I say for such a query, you can use a join to the hall table, and then get the specific ID for that. Use that join to get you all the students that actually work in the hall. You can also do a subquery where select all from duty, where name is equals to hall. You can also go query, get the ID, and then come and use it like I did here. So 3 ways. Which is the best one? A join. A join is the best one, followed closely by a subquery. But they all do work. You just don't want to be manual at the end of the day. That's my point. Fetch the first 10 students. So let's say we have 1 million students and we just want the top 100 students. You can use a command for limit. So select all from student, limit 10. So if I limit by 100 and my students are 26, it doesn't do much. It just brings me the 26. But in this case, my students are more than 10. So this brings me the top 10 students. And lastly, another question we could ask ourselves is, what duty has more than 3 students assigned to it? We went through we did a similar query where we found the count of students by duties, and we saw most of them had a count of 3, 3, 3, but one had a 4. So in this specific one, we want to see the ones that the students are more than 3. Because it's special, we want to know you. So this is how we do it. Select count all, or you can specify a column. That's up to you. And then the duty ID. I use the duty ID here for group by. All the columns that you use also need to be in the group by clause. So duty ID, if I add first name, I would also have to add first name here, and so on. So select count all duty ID from student, group by duty ID. We've introduced a whole new term here, having count all to be greater than 3. So what is having? Having is basically similar to where, except the difference is it doesn't have access to the select column, like the new computed columns, the aggregate functions and all that. So what you do is now use that, introduce having to handle such cases. As you can see, for where we already had access to these columns, we have where is mostly accessing the columns. But now having is accessing the select, like columns in the select queries. But basically having now has access to the select column and columns that we create on the fly in a way that where doesn't, and that's where comes in. And we run that, we only see there's only one duty that has more than 3 people. And that's it on select statements. So I thought to do that to introduce you to most of these. We'll go to the next set of SQL commands, which is data control language. These are commands focused on defining permissions, access controls, and security for database objects. So this type of commands allows administrators to grant and revoke access to data and manage users' permissions within the database, helping to ensure data security and control. We have 2 examples of these. We have grant. It gives specific permissions to a user or role, such as select, insert, update, or delete, access on tables, views, and other database objects. So grant, we are granting this access to an admin here, so I'm going to give them everything. There could be more, but I'm going to give them select, insert, update, delete. On student 2, a user called admin, a user was an admin. So in this case, I feel like they need to have rights to do all this. But I've noticed there's a teacher who can delete students, and we don't want a teacher to be able to do that. We also don't want a teacher to be able to update. Technically, you'll see what works for your system better. But let's say we don't want a teacher to be just able to go and update student details without more checks there. So we revoke, update, and delete commands on student from a teacher role. And that's what revoke does. Let's look at the last set of commands, and that is the transaction control language. So what is this? It is a set of SQL commands used to manage database transactions. That introduces something. What is a transaction? I talked about it in my last video. Anyway, transactions are sequences of operations that are treated as a single logical unit of work, ensuring that the operations are either all successfully completed or are rolled back in case of an error. So all or nothing. If I start this, I need to complete. If I don't, I have to go back to the state I was before I started this transaction. They maintain data integrity and consistency, especially in multi-step processes. So maybe I have a set of transactions that I need to run. One, insert, do this, and they all need to go in together or none at all. So in this case, those are my transactions. And because especially in multi-step processes is what I mean. When I need to think of all of them together, then I need all of them to run and to completion. And if an error occurs maybe in step 5, I need that to roll back to the previous state so that I leave it in a stable state to begin with. I don't have a case where I don't know where my transactions ended. Maybe it executed to the 5th. Should I start from the 5th or should I start again from the stop? We don't want that scenario in the first place. So let's look at some examples. We have commit. It saves all changes made in the current transaction permanently to the database. So we have an update command as an example, after which we have a command commit. We have another one, rollback. It reverts all changes made in the current transaction back to the last commit point, undoing any changes made within the transactions. I've explained this. If it gets to stage 5 and it can't continue, I need to roll back to the state I was before I started executing my commands in the first place. So that's what rollback does. We have 3 more. We have save point, we have release save point, and we have set transactions. So those are all the SQL commands. Let's look at data types. We have different types of data types. What are they? They specify the kind of data that can be stored in a column. They help ensure data integrity and enable efficient storage and retrieval by allocating appropriate space for each type of data. So in this case, this is what we mean when we say var 50. I want it to have a maximum of 50. It can be less, but I want it to be within, I don't expect maybe my email to be 100 characters, so I can maybe put a cap on at 50. In that case, I'm allocating appropriate space for it. Of course, also, I don't expect my email to be int, so that's what I mean. So we have different types. We have numerical data types. We have, under numerical, we have int and integer. We have float, real, double precision. So int is for whole numbers, float is for approximation, and decimal is for exact, give me to this number of points, decimal places. Aside from numerical data types, we have string data types. This is where char comes in, var, text. These are named differently in different databases. I've seen in pgadmin them calling var character varying. What they mean is the same, varying characters. We have date and time data types. So date covers date only, time covers time only, timestamp covers date and time, and interval covers things like, give me, I will use the last 2 days or the last week. So that's an interval in this case. We have Boolean. This is your true and false, yes or no, y or n. Depending on 1 or 0. Binary data types, this stores binary data such as image files, and we have blob, which is a big, large binary. JSON and XML data types, when you want to store your JSON, when you want to store your XML, you use these data types. We have enum, which gives us a specified set of options. For instance, I only want my options to be low, medium, and high. So in this case, you can only assign one of these to this column when allocating it. We have array. We can have an integer array, we can have a string array, we can have a Boolean array, and so on and so forth. Basically, array is a collection of another data type. And lastly, we have special data types, and this is where you have things like UUID, a universally, or GUID. Anyway, universally unique ID. So read up on that, but it's basically, you can use it instead of ID in some cases. I do prefer it because it's not easily predictable, plus I have way more options, but that's just a preference. You can go with UUID instead of using ID, like an incremental way of doing things. My simple reasoning is usually someone can't predict anything, but they would also need to have access to the data and have so much information to get to these details, so I'm not worried about that. We have geometry. This is where you place your points. For instance, I have a specific location and give me the coordinates, which are X and Y. Then you use things like that. And finally, we have serial. Serial is an auto-generated, auto-incremented int value. It has an increment gap, like increment by 1. It starts from a specific figure and so on and so forth. So that's what serial does. Let's look at constraints. We've gone through data types, and lastly, let's look at constraints. What are constraints? These are rules applied to columns or tables to enforce data integrity and validity. What are some examples of these constraints? We have different types, so we'll look at most of them. We have primary key. This is a constraint that auto-increments. It's unique. It's not null. Technically, no, it doesn't. The auto-increment is a different thing. So I'm sorry about that. That's not a constraint on its own. We have a different constraint, which is auto-increment, and this is mostly for MySQL, and for Postgres, we use serial. I don't remember. I've actually not worked with most other DBs on this in a while, so just check what you're using for your DB. Anyway, we have primary key. It is unique, and it's not null by default. And it's mostly, we have one primary key per table. That is usually one column, but it can be pointing to different columns, but that's a whole different thing. We have foreign key. This is basically a referential key that points to another reference table, to a unique column in that table, or a primary key to that table. We have unique. This ensures, for instance, I want to track my users and they need to have a username. I can't have two users with the same username. So when I have the unique as a constraint, then the user will be forced to create another username instead of me having to have two Waideras in my user table. We have not null. This is also self-explanatory. It ensures you actually have to populate your column and you can't leave it blank. We have check. Here you give it a check. For instance, I only want to add users to this table if their age is above 18. When adding, so I first check the age. If the age is greater than 18, then you can come in. If it's less than 18, we're sorry. So that's an example of a check. Default, basically, we give it a default value for when we've not provided a value for that column. For instance, I don't provide gender, and most of my students are female, so I can have a default of female, and then after that, only specify when they're male. This is a bad example, I know that, I promise. I couldn't think of anything else at the top of my head. I have already covered auto increment and serial, and that's it. That's it for introduction to SQL commands. I hope you've learned a lot. I hope you can code on your end. If you want me to share these scripts, I can share them. You just need to go create the DB. I've also shown you the link on the database I used. I'm going to add it to the description, so feel free to check that out and actually prepare, like do that on your own end. And yes, happy learning. I really hope you learned and picked up something. My name is Waidera Wangui from Kodarasa, and I hope to see you again next week. Thank you.